so far in this chapter, we've talked about inverse functions. We then kind of like did this weird whiplash thing. We switched to exponential functions, and now we're talking about logarithmic functions. And it seems like they're all different topics, but if we kind of put everything together, we basically tackled exponential functions, and logarithms are actually the inverse of an exponential function. So just how addition and subtraction cancel each other out, and multiplication and division, squares and square roots, they cancel each other out. Well, logs and exponentials cancel each other out as well, okay? So I think the first thing to do is just try to figure out like what are logarithms? Like what does it actually mean? And to do that, I think the best way to think of it is to start with exponentials. So to see what exponents mean, okay? Yeah, perfect. So exponents really mean repeated multiplication. If you do that in your calculator, you should get like what, 32 as 2 to the 5th. Okay, so one thing we can do is we can write this as 2 to the 5th power equals 32, right? And just some notation, right? Usually we call like the bottom number the base, right? We call the exponent or the power. And then 32 like doesn't really have a name, but I'm gonna call it like the final answer, right? That's what we get at the end, okay? So this is exponential notation, right? We're just raising something to power and writing what it equals to. But we actually have a similar way to write this using like what's called logarithmic form, okay? And let me kind of lead you through this. And I think it's easiest to see with an example, okay? So we know that 2 to the 5th is equal to 32, okay? Let me show you how to write it using logarithmic form, okay? Well, we're gonna do this. We're gonna write log, okay? The base of the exponent becomes the base of the log. So it goes like underneath the log almost. It's a subscript, okay? We're taking the log of 32, okay? And I'm gonna say that that equals 5, okay? Now these two things, 2 to the 5th equals 32, and this log 2, 32 equals 5, they mean the same thing. They're conveying the same information, okay? Except now the information is written a little bit differently, right? Now the base is underneath the log, okay? Now the final answer is on the left-hand side of our equation, right? And basically we're saying that the log equals the power, okay? So instead of taking a number and raising it to power and getting the final answer, we know the base, we know the final answer. Our question is, okay, what's the power? Like, what do I need to raise 2 to get to 32, okay? And I'll show you an easier way how to think about it, okay? Now, before we talk about that, I guess we have to talk about how we like say things, right? If you wanted to read this aloud, I would say this: log base 2 of 32 equals 5. Okay, that's how I would say that aloud, okay? All right, let's do another one. 2 to the 0 power. What is 2 to the 0 power? 1. Good. Anything to the 0 power is equal to 1. Any guesses on how I'd write this in logarithmic form?
Log base 2 of 0.
Not of 0, but of 1. Good. Equals 0, right? So the base goes on the bottom. It's still the base of the log, right? And then our final answer comes first before we get to the final, or where we get to the exponent 0, okay? So we'd say log base 2 of 1 equals 0. Okay, so that's how we talk about logs. Okay. Finally, what's 2 to the negative 1? So remember, flip the line, change the sign. 0.5 or 1/2, right? So when we change the sign to a positive, we just flip it over the line. So it's 1/2 or 0.5, right? Okay. So negative exponents just give us fractions, okay? Now, if you wanted to use this using log notation, I'd say log base 2, right, of 1/2 equals -1, right? I put parentheses around the 1/2. You really don't need to, but I think when you have a fraction, it's kind of hard to see like the difference between the base and like what you're taking log of. So I put parentheses when I do that. Now, I'm pretty sure you know how to say that log base 2 of 1/2 is equal to -1, so I'm not going to write that down. But this is kind of the notation that we use for logarithmic form.
Why would we
Because sometimes we're not like when we're trying to figure out what 2 to the 5th is, right? We get 32, right? And that's something that we do a lot. But sometimes we're not interested in like what 2 to the 5th is. Sometimes I know that the base is 2. I know the final answer is 32. I just don't know what the power is. And we need like notation to talk about like what a lot of the times actually there's plenty of applications with logarithms. Gosh, I can't even think about it on the top of my head, but there's a bunch of yeah, logarithms show up, I think, a lot in like chemistry, science applications, even business, I think. But I'm gonna have to, I don't have anything on the top of my head. Now I'm on the spot, I can't even think of it. All right. So let's say I wanted to figure out what log 3 of 81 is. Okay. So I'm just gonna write this out, right? Log 3 of 81. Okay. And I want to know like what that number is equal to, right? Now, just thinking about the definition of what a log is, I know that 3 is like the base of the exponent, right? 81 is like the final answer. Okay. So when you see this, you're really thinking like, what is the power that I need to raise 3 to get 81? Okay. And let me write that out. Okay. What power might I raise 3 to, yep, to get, let me do, so that the answer is 81. Okay. Now, it is kind of hard to think about that. Like, okay, like 3 to the what power is 81? Okay. Personally, I think it's easier, and I think students find it easier this way, is when you're trying to find a log, I think it's easiest to write it in exponential form first, and then it's easier to conceptualize like what I need to do to figure out what the answer is. Okay. And the way I do it is, well, I want to know what log 3 of 81 is. So I'm going to say, okay, log base 3 of 81, that's equal to something. I don't know what it is. I'm going to call it question mark. Okay. Next, what I'm going to do is I'm going to write this using exponential form. So it's kind of like starting from this column and going backwards, right? Okay. What's the base of my exponent? 3. What's the power of my exponent? X, or like question mark, right? Okay. Equals, and what's my final answer? 81. Good. So now I took my logarithm and I transferred it into exponential form. And now it's really easy to figure out, okay, I need to figure out 3 to the what power equals 81, right? Any ideas on what power it is? 4. Good. Now, if you're like kind of, oh, yeah, if you're like, I can't do that in my head, right? I was just about to say that, right? If you're like, okay, I can't think about this in my head. I'm going to say in my class, I'm not going to give you anything too complicated, right? I'm not going to make it like 3 to the 15,000th and third power, right? And then you're going to have to test every single one. Usually I'll give you like the first power, the second, third, maybe fourth and fifth, but I'm never going to go like past the 5th power unless it's like a really small number like 2. Okay. So what I do, my strategy here is I do this. Okay. I need to figure out some powers. What's 3 to the 0 power? 1. What's 3 to the first power? 3. What's 3 to the second power? 9. What's 3 cubed? 9 times 3? 27. And 3 to the 4th power is 81, right? And then you kind of just keep going and going until you get not really. I mean, of course you could just use your calculator and
Well, that's the problem is, my problem is, there is a log, but I like that if I told it how it works. It says log, and then it gives a parenthesis.
yeah, and that's a different type of log than this. We'll learn what that means a little bit later in this packet. But what I would do is I would just go in your calculator, be like, okay, 3 to the 0, 3 to the first, 3 squared, 3 cubed, 3 fourth, and just keep doing it. I mean, I'm not going to give you like 3 to the 11th or something. So you're going to hit it soon. And you're going to find out that 4 is the answer, right? 4 is the power that you raise 3 to get to 81. Okay. Now there are a few more that you have to check. Okay. But we'll talk about that on the next page. Okay. Well, let's go to the next page and see what other values that we can check for. Okay. We want to do log base 4 of 1 over 16. So yeah, I need to figure out what number that is. Can someone tell me what the exponential form for this would be?
4 raised to the x.
Mm-hmm. Yep, 4 to the what power equals 1 over 16. That's the exponential form, right? So, I mean, of course, we can go and find powers of four, like 4 to the 0 is 1, 4 to the first power is 4, 4 squared is 16. I don't even know what 4 cubed is. I'd have to do that. My calculator is probably like what, 54? Good, okay, nice. And
Would
then,
this be
yeah,
over
like,
-2?
ooh, that's a good idea. Let's think about negative exponents.
Because it would just be, yeah, because the numbers would say the same, it would just flip the line. So you don't
Yeah.
really necessarily need to test. It just means it's always a positive. If it's 1 over whatever the number is, you just make it negative.
Yeah, perfect, right? So you can tell that the positive numbers aren't working, right? So as we go to the negative numbers, 4 to the -1 is 1 over 4. 4 to the -2 is 1 over 16, right? And I mean, we just hit it, right? I know that -2 is the answer to this one. Okay, so it's kind of like guessing and checking almost. I'm not going to give you anything too complicated. Yeah.
How do the negative exponents work? How do they ensure if they like a fraction?
Yeah, so basically, if I wanted to do, let's just do 4 to the -2, right? Now, when we flip the line, we change the sign, flip the line, right? So this becomes 1 over 4 to the +2, right? And then 4 squared is 16. Another way you can think of it is the negative power is just 1 over the positive power. Yeah, yeah. That's kind of how I do it.
So this question is, in the future, not in your class, but in the future, if we had something that had to go to like 50 power or something, would that ever pop up? B, how would it look like?
Yeah, it would pop up, but you have calculators for that.
Yeah, but you can't just go from like 1 power, you can't just keep going.
Well, actually, your calculator, and I don't know if yours does have it, but there's actually a log button on like higher power calculators, where you can put the base and like. So usually, what I would do is I'd go on like Desmos, do log base 3 of I don't know 6,000.
Mine doesn't actually have, it only has the long parentheses, it doesn't actually have a long.
Yeah, I don't know. I'll have to look after class, but yeah, there's actually a very specific definition for just the log. Yeah. All right, let's do some more. So let's do example 4. We want to do log base 3 of 9, right? Okay. Now, if I wrote this in exponential form, well, this is equal to question mark. How would I write this in exponential form? Perfect. And well, what power of 3 gives me 9? 3 to the second power. Perfect. All right. How about this? I have 3 more for you. Okay, I want you to try these. The last one is kind of hard. Okay, so if it stumps you, don't worry because I did that on purpose. And then we'll come back. So let's come back up to the front here. I got Island to do log base 5 of 625. You want to take us through that one, Island? Yeah. Yeah, so you just counted, okay, I need to multiply 5 by itself 4 times. I got 625. Nice. All right, Dagan, take us through the log base 6 of 1/6.
Solves a fraction, so I know it's negative exponent.
Mhm.
So 6 is the denominator. To get 6.
Mhm.
Flip to the power of 1, so turn it negative.
Yep, perfect. Just by the way, on Alex, like this would be your answer for log 5 of 625, and your answer for Alex on like homework or stuff for this one would be like -1, right? All right, perfect. Nice job. Let's just talk about the last one for a second. I think I was pretty surprised when I was walking through because it looked like we all got this one. So if I wrote this in exponential form, right, I want to figure out what that number is. So basically, I'm asking myself, 4 to the what power equals 2, right? I'm sure you've checked 0, 1, 2, 3, 4. They all give you like really big numbers, bigger than 4, right? You probably tried the negative numbers and you got fractions, right? So that's not going to give you anything. What power of 4 equals 2? A half, right? Yeah, so 4 to the half power. And the reason I would even think of a half power is what's another way to write the half power? Not divide by 2, but remember square roots? Yeah, half powers are actually roots, right? So
Oh,
the
that
one
makes
half
sense.
is the same thing as the square root of 4, which is why I even thought about, okay, I know the square root of 4 is 2. Square root's the same as the 1/2 power. So the answer has to be a half, okay?
I just kind of did it like just intuitively.
Yeah.
Logic, not really necessarily knowing why it was.
That's true. Like it's like a half of a power, right? That makes sense. Yeah. So
Okay.
yeah, so for my class, I'll do so any like whole numbers, right? I won't go like past 5 or anything. Negative numbers, same thing, right? And then you kind of have to check to see, okay, if those don't work, then maybe fractions. I'm not going to give you a crazy fraction. I might give you a half, like a square root. I might give you a third root, but yeah, I'm not going to give you like the fourth, fifth, sixth roots because that would just be a little crazy. And I don't know what those are in my head either. All right.
Actually,
The third root's okay.
if in the third root, I don't know how to figure that out. Unless I do every single other thing I know it's not.
Yeah, just try all the other ones
Yeah, I
and
try
then
to-
yeah.
Okay, ask you.
Yeah.
You're only doing square for roots, right?
Yeah, like I don't think I'm gonna go any further. I don't think I'll do a fourth root. I think that's just kind of
If you
mean.
do, I'll be screwed. I can only do a square root.
All right.
My calculator.
Well, you guys can yell at me if I give you a fourth root. I'll try to stick with the 2 and 3. Okay. All right. So I think you've seen on your calculator that there's a button for log that doesn't have anything attached to it. It's not log base 2 or anything. Yeah. So we have this thing called the common logarithm. It's just log with no number on it. The reason why base 10 is such a common logarithm is because we live in what's called a base 10 number system. So for example, we have 10 fingers, right? And we have 10 toes. When we count money, we count by tens. So, I mean, this like world right now is like based 10. 10 is a very common factor that we count by. So that's why 10 is so common. Okay. Okay, so whenever you see like log without anything on it, just know that it means log base 10. It's just that mathematicians are so lazy to work with log base 10 that we don't feel like writing log base 10 all the time. So we just write log x. Whenever you see log x, it's just base 10. Okay. Yeah. Another common one that you'll see a lot is what we call the natural logarithm, basically E, right? E is a number that shows up a lot in math and a lot of applications. So sometimes we'll see log base E, but that's just kind of clunky. So instead what we'll do is we'll write ln of x, okay? It's technically called like the natural logarithm of x, but most people will say ln x, and everyone knows what that means, yeah. Okay, so these are just other ways we can look at logarithms. Okay, let's do example 5. We want to do log of 10 million, okay? Now if you see log by itself, what base is it? 10, good. So this is log base 10 of 10 million. Okay, and if I were to write this in exponential form, well, 10 is the base. I'm raising it to a power that I don't know, and I know the final answer has to be 10 million, right? Okay, what power of 10 gives me 10 million? 7, good. Okay. Yeah, I will say, like, I did promise that I'm not going to go up too high. With base 10, like, that's kind of easy, right? Because it's like, you just plug it in, you see how many zeros there are, you get 7. Okay.
Okay. Wait. Yeah, there is a. Okay.
Yeah. Let's go down to ln e of 5. Okay. Now, remember, ln is e, right? So we can write this as log base e of e to the 5th. Okay. And there's 2 ways I like to think about doing this problem. Okay. So I'm going to split this into half. Okay. One way we can think about this problem is by writing it in exponential form. Okay. What would the base of my exponent be? Good. E to the what power equals, what's my final answer? E to the 5, right? So now I'm asking myself, okay, what power of E gives me E to the 5th?
5.
5. Perfect. Right? Yeah. So pretty easy to think about, right?
Okay.
The 5th power of E is E to the 5th. Another way we can think about it is thinking about inverses, okay? So I haven't really talked to you about this yet, and we'll talk about this in more detail later, okay? But logs and exponentials cancel each other out, okay? I have an exponent here, I have a log here. If the bases are the same, we can actually cross some stuff out, okay? It looks kind of clunky at first, but I promise you it gets easier as you go on. What cancels out here is the log base E and the E base. but everything else stays the same.
5.
So yeah, we're left with 5. Okay. So two ways you can go about thinking of it. I like the one on the right better, but I mean, technically, traditionally, the one on the left is like exactly what's going on. Okay. Yeah. All right. Why don't you try the next two, log of 0.1 and ln of e, and then we'll come back. Let's come back. I know I didn't give you that much time to work on it, but we'll come back. So let's do the log of 0.1. Remember, log is base, which power? Or 10, good. So this is really log base 10 of 0.1. And I know that there aren't any fractions here, but you can still kind of figure it out, right? If I write this in exponential form, right? What's the base? 10 to the question mark power equals 0.1, right? What power of 10 gives me 0.1? -1, right? So you kind of just guess and check to see what it's going to be. You can do it in your calculator. But yeah, that's what you get. I think the tricky one here is ln of e, okay? Ln is log base what? E of e, right? Okay. Let's do it both ways. On one hand, we can ask ourselves if this is equal to question mark, right? This is the same thing as asking ourselves, okay, e to the question mark equals e, right? Well, what power of e gives me e?
1.
1, right? So that's one way we can think of it. I feel like a lot of people do like crossing out though, and I like doing it too. Let's go ahead and do that. Log base e of e, okay? If I start crossing out, I'll cross out the log e, I'll cross out the e, and at this point, a lot of people are like, okay, well, nothing's left, so I guess the answer has to be 0, okay? Or undefined, right? But let me show you a trick. Yeah, e is e to the first power, right? So I know it's not written, but that 1 is being hidden there, right? Every number can be written as that number to the first power. So really what's left is the 1. Okay. Any questions on these guys here? All right. I kind of want to go through some properties of logs. And to do that, the first thing I'm going to do is talk about how, well, logs and exponentials are like the inverses of each other, which we have talked about, okay? Now, logs and exponentials are inverses, but there is a catch. The bases have to be the same, okay? So log 3x will cancel out 3 to the x because the 3's match, right? Like log of, I don't know, 105,293, it would be the inverse of this function. They would cancel each other out. If they have different bases, they can't cancel each other out, only if they're the same, okay? It goes the other way as well. So if I wanted to find the inverse of 2 to the x, it'd be log base 2 of x, okay? All right, I have some properties of logs. You'll hear about log properties later. These aren't like real properties of logs, but they're things that are true. And the way I like to introduce them is just through an example, okay? Let's start with the first one, okay? Let's see if we can figure out what log base 5 of 1 is, okay? So let's say I wanted to ask you to figure out what that is, okay? How would I write this in exponential form?
5.
Mhm. Perfect, right? 5 is the base, 1 is the final answer. What power of 5 gives me 1? 0, right? So log base 5 of 1 is equal to 0. Was there anything special about the number 5 here? No, right? I could have found log base 10,000 of 1 or log base e of 1 or anything. The answer would still be 0, okay? So we actually have a property of logs basically that says if I have any log and I take the log of 1, it's going to be 0 no matter what that like base is, okay? Personally, I don't really think this is a property you need to memorize because you can kind of just like parse it out this way, right? It's not like something you need to know, but if you see this and you want to do it fast, log of 1 with any base is just 0. Okay. Any questions on this example? Sounds good. All right, let's do another one. I'm going to give you this question. Log base 3 of 3. See if we can figure that one out. How would I write this in exponential form? Yeah, 3 to the question mark or x equals 3. What power of 3 gives me 3? 1, right? So what this property is going to tell you is, well, there really wasn't anything special that I had 3s, right? If I did log base 5 of 5, it would still be 1. Actually, as long as the base and the final answer match, it's always going to be 1, right? And because of two things, right? It's kind of like what we did on this last question where we just canceled them out and we're left with 1, right? But just thinking about what it means, like 3 to the first power is equal to 3. So whenever the bases match, they just cancel each other out. Okay. Moving on, let's do log base b of x. So let me just show you an example here. Let's do log base 2 of, let's say 2 to the 5th power. Okay. Let's see what happens here. Okay. Now, a couple things we can do here. Let's just cross out and see what happens. What would I be left with if I crossed out the log and the exponent or the exponential? Yeah. Okay, let's cross out the 2 and the log 2. So what are we left with? 5. I know you guys said that, and then I gave you like a weird look, and that's literally because my brain just like stopped working. But yes, it would be 5, right? Okay. So what this rule is saying is basically if you're doing like log, it's basically like this rule, except for if there's an exponent, the exponent's just like left there, right? Okay. Last rule, this involves like exponentials. Okay, so instead of like taking a log, we're gonna take an exponent and raise it to a log. Okay, so we actually haven't seen this yet. Okay, let's do 7 to the log base 7 of x. What do you think we'll cross out? The 7. Yep, the 7, the log 7 will cancel out, and we're just left with the x. Okay, so it works both ways. The exponents and logs cancel each other out the same way. Even if you like flip them and you're doing an exponent to a log or you're doing a log of an exponent, they both cancel each other out as long as the bases match. Okay. Any questions on what we just did here? Okay. Now these guys, honestly, I don't think that these are rules that you have to memorize. Like I don't want you like putting these on flashcards and memorizing the rule. I think that's kind of dumb. What I would do is think about, okay, like I can cross out, didn't mean that. I can cross out like the log and the 7, right? And I can cross out these guys. And then it's kind of intuitive to see like exactly what's going on. It's just kind of weird to look at the rules at first because crossing out a log base and an exponent just like is kind of strange, right? Okay. Let's do example number 6. So this example, I have a bunch of these. I promise you it's not as bad as it seems. These kind of go fast. Let's start with log base 3 of 3 to the 10. What cancels out here? Yep, log 3 and 3. What am I left with? 10. Perfect. All right. Let's skip over to let's do this one. Let's do log 10. Okay. Now, what is the base? Even though it's not written. 10. Good. So this is log base 10 of 10. Okay. What cancels out? Everything. And what am I left with? Actually 1, right? Because this is 10 to the first power. We're left with 1. Okay. Let's do log square root of 7 of 1. What is the log of 1 no matter what? 0, right? So that one, literally just 0, right? Let's skip down to the bottom corner. Okay. 5 log 5 of c squared plus 4. What cancels out here? 5. Yep, just left with c squared plus 4. All right. Any questions on what I've done so far? All right. How about this? I'm going to give you some time to work on the last 5. They should go pretty quickly, and then we'll come back. All right. Let's do ln e squared. Now remember, ln, what's another way of saying ln? Log base e of e squared. What cancels out? Everything but the 2, right? So we're left with 2. That's our answer, right? Let's do log base 11 of 11. What's that answer? 1, right? If the bases match, just 1. Okay. What's ln of 1? 0, right? Any log of 1 is 0. Moving on here. This one's a little tricky, but what is the base of just log 10, right? So I can write this as 10 log base 10 of a squared plus b squared. And, well, these guys would cancel out, right? So all I'm left with is a squared plus b squared. That's it. What would cancel out on the last one? everything but the square root of 2, right? So that would be the one that's left. All right. Any questions on logs? All right, I think